Greetings, Professor. Myself, Ashima. And on the behalf of Group 6, this is the Midterm Project Status Update. The name of our project is LAPD Crime Analysis. Table of Contents. That includes about LAPD, about the project, meet our team, and then the project status, requirement phase, design phase, development phase, then the challenges encountered, project cost, and then finally the recommendations. About LAPD. LAPD is Los Angeles Police Department. It is a law enforcement agency that upholds the public safety and enforces the law across the Los Angeles, California. About our project. In order to prevent crime, LAPD recognizes the power of data-driven solutions. So our main objective is to develop a machine learning model that accurately predicts the crime classifications based on historical data, including date, time, location, and crime code, and then to utilize the techniques in order to pinpoint the crime hotspots within the city of Los Angeles. Meet our team. We have Priyasha Sharma as business analyst, Kriti Kumati as technical lead, Anujit Sivach as business analyst, and then myself Ashima as the team leader. Our project status. Project status is on track. Let's jump to the communication plan. So basically, the communication plan includes 6 weekly status reports. The first one includes the reviewing of project charter, project proposal, and then the pre-planning of the project. The second one includes the data cleaning that's done in Microsoft Excel. The third weekly status report includes the data cleaning and data analysis that is performed in Python. And for the fourth one, additional data analysis has been conducted in order to understand the use of weapons for the crime. The fifth weekly status report includes machine learning model. For the fifth one, we used random forest machine learning model. And then the sixth weekly status report includes the KNN, that is K nearest neighbor machine learning model. The mode of communication is basically Teams meeting. Requirement phase. So the first very basic requirement for the project is the dataset. We have the dataset that comprises all the criminal records within the city of Los Angeles dating back to 2020. It includes around 800,000 data records that includes 10 qualitative and 18 quantitative attributes. And then we prepared a data dictionary that gives us a deeper understanding of our dataset. It provides us a detailed description for each data attribute, making it easier to interpret and analyze the data. And then comes the design phase. Design phase includes 2 subphases. The first one is data cleaning, and the second one is data analysis. Basically, the data cleaning is done in Python by addressing missing values and providing descriptive labels for the categorical data. It is done in order to prepare the data for the data analysis. That is again done in Python. That provides us a deeper understanding and exploration of the dataset, helping us to identify patterns, trends, and insights to the data. Now, I would like to hand over to Priyasha.
Thank you, Ashima. Greetings, Professor. My name is Priyasha Sharma, and I am the business analyst of this project. We will now look into data cleaning and data analysis that we have performed on the gathered data. We have uploaded the source Excel file into Jupyter Notebook, and we have observed the details about each attribute of the table. From the observation, we found unreadable data, unformatted time data, unwanted white spaces, and missing values. We have a column named MoCodes, which contains the code of describing how the crime had occurred. The description for each MoCode from the LAPD website, and with a custom function with mapping capability, a column that will combine the description of MoCodes is created. The time occurrence column has the time in 24-hour format without any colon, which is corrected to proper 24-hour format using string functions. We also observed some irregular white spaces in 2 columns, that is, location and cross street. We have removed the white spaces from these columns again using string functions. Finally, we have replaced all missing values with unknown or NA based on the type of a column using fill NA function. Let's look into the data analysis. We have created some charts that will give an overview about the crimes of Los Angeles. The libraries Pandas, NumPy, Matplotlib, and Seaborn are used for the charts. A time series line plot is created that describes about the count of crimes occurring in Los Angeles every year. From the chart, we can see 2022 at the highest with 234,000 crimes and 2023 at the lowest with 156,000 crimes. Moving on, we have a column chart that distributes the crime based on area of occurrence. From the chart, we can see Central, 77th Street, and Pacific are the top three areas with the highest number of crimes, and Mission, Hollenbeck, and Foothill are the three areas with the lowest number of crimes. Next, we have a horizontal bar chart that displays the top 10 crimes in LAPD along with their counts. We can see that stolen vehicles is the most occurring crimes of Los Angeles with a count of 85,000, followed by battery assault with 63,000 and theft of identity with 50,000. Next, we have a histogram which shows 29 as the mean age of victims, and we also have bar charts for gender classification and victim descent classification. As we can see, these charts show some demographic information about the victims. Moving on, we have constructed a map using Folium library that plots the information of crimes to a map. As the dataset is huge, we have taken the most recent 10,000 open cases. This map displays information such as the description about the crime data, area name, victim gender, and other such details. As we have a secondary objective to identify crime hotspots, this would help as a starting point for the objective. The circles in this map are of three types: green, yellow, and orange. Green is for areas where there are less than 10 crimes in the past 3 years. Yellow is for 11 to 100 crimes, and orange is for more than 100. This gives an overall visual about the pending cases of Los Angeles. Now, Kriti will continue with further data analysis and development phase of our project. Thank you.
Thank you, Priyasha. Greetings, Professor. I am Kriti Komati and I am the developer for this project. We will continue looking into the remaining parts of data analysis and also about the machine learning models that we have implemented for our project. Continuing our data analysis, we also created some visuals that gives us an overview about the type of weapons used for crime in Los Angeles. A bar chart is constructed that displays the top 10 weapon types that are used for committing a crime. Surprisingly, the most common type of weapon is the human hand and leg. We also have a box plot that displays the typical victim age for a weapon type. Next, we have a pie chart that uses a filter for area, so we can have the top 5 weapons used in each area. This filter is dynamic and the pie chart will adjust based on the value of the filter. Next, we will move on to the development phase. We have split the process in 3 steps: data preparation, data modeling, and data visualization, which means first we prepare the data for each machine learning model. Second, we develop a code for running the machine learning model. And then the final step to interpret the results using visuals. Currently, we have executed 2 machine learning models, random forest and k-nearest model. For random forest, we have removed all unwanted columns from the data. As random forest work only with numerical data, we have used label encoder to numerize the categorical values. Then, regarding the date, we have split these columns into separate columns for date, month, year. For handling missing values, we have used a simple imputer to fill the missing values. We have split the data into test and train with 30:70 ratio. Then we have prepared the code for random forest that will give us the accuracy, precision, recall, and F1 score. After execution, we found all these values to be above 99%, suggesting that this model would be suitable for our objective. The bar chart describes about the important feature in ascending order. Next, we have a nearest neighbor model, where we implemented a similar data preparation strategy. For our code, we have split the data again with 30:70 ratio, and we have given the number of neighbors as 3000. This number is feasible as the total number of records in data is more than 500,000, hence avoiding overfitting and underfitting. For this model, we got the accuracy score to be 23.55, suggesting that this model is not suitable for our objective. Further, we have a visual that describes the accuracy with increasing number of neighbors. The highest at one neighbor that gets an accuracy of 35. Next, Anujit will walk us through the recommendations, project cost and challenges.
Thank you, Kriti. I am Anujit Sawaj and I serve as a fellow business analyst within the team. Let's delve into the recommendations which are outlined in our current slide. The existing recommendations underscore the importance of regularly updating crime data to ensure accurate predictions and efficient resource allocation. Additionally, there's a strong emphasis on developing an intuitive interface for LAPT personnel to interact with predictive models. Ensuring transparency in model utilization is paramount for building and maintaining public trust. As we move forward, our focus should extend to data quality, interpretability, and comprehensive documentation. This entails consistent data cleansing and preprocessing to uphold model accuracy, enhancing model interpretability, and thorough documentation of the models, including their structure, data prerequisites, and key assumptions to facilitate their long-term maintenance and future updates. Transitioning to the next slide, we have project cost. The project has been allocated a budget of $30,000 meticulously calculated to encompass all expenses, including personnel, materials, and unanticipated contingencies. Adherence to this budget is of utmost importance, with any deviations necessitating prior approval. To maintain strict financial control and ensure the project remains within the budgetary boundaries, continuous monitoring and transparent reporting are indispensable. As we move forward, we encounter ongoing challenges. One of these is the need to ensure the project's adaptability to evolving crime patterns and community requirements. To tackle this, a continuous exploration and integration of additional data sources is necessary to glean insights into changing crime trends. Another challenge lies in the class imbalance often found in crime data, which can introduce bias into our models. The solution here involves assigning variable misclassification costs to different crime types, with a higher weight allocated to less frequent ones, thus encouraging the model to prioritize rare crimes. Furthermore, the growing complexity of our models presents difficulties in explaining predictions and maintaining trust. To address this, the development of visualization tools such as feature importance plots and partial dependence plots is indispensable in making complex models more interpretable. In our coming endeavors, the project aims to complete the development of two new models, specifically logistic regression and support vector machine, that is SVM. Within the coming weeks, these additions are expected to significantly enhance the project's crime analysis capabilities, contributing to our pursuit of more effective and insightful crime predictions and management solutions. We are grateful for your continued support, guidance, and insights as we work together to create a safer and more secure environment for all. Thank you for your time, and we are eager to answer any questions or address any concerns you may have. Thank you, Professor.